So I don't have my green folder right now. Not sure what I did with it, but let me try to write without this green folder. I'm not sure how well it's going to work because of the wood grain on this desk of mine. Anyways, each of the problems in section 4.2 asks me to factor, and every single problem in section 4.2, when we actually get into the problems, will have exactly 4 terms, not more than 4 terms, not like 5 or 6 terms, not less than 4 terms, not like 3 or 2 terms. When I'm asked to factor a problem that has 4 terms, there are only a handful of techniques that are used to factor problems that have 4 terms, and over 90% of the time, the technique that we're asked to use to factor a problem that has 4 terms is the technique called factoring by grouping. And let me just kind of jump into what factoring by grouping involves. It's not particularly hard if you're good at common factor factoring. If you're not good at common factor factoring, factoring by grouping is awful. So before we jump into this section, if you're not feeling good about section 5.1, you got to get that mastered. It turns out that section 5.1, your ability to factor out the greatest common factor will determine your success in section 5.2, in 5.3, in 5.4, in 5.5, and 5.6. It's hugely important. So if I see a problem with 4 terms and it tells me to factor, and even if it didn't say factor by grouping, what I'm going to do is I'm going to split the problem into groups of 2 and factor by greatest common factor factoring twice. So in problem 2, I'm asked to factor x squared plus 3x plus 4x plus 12. Some of you that are experienced at factoring will add the 3x and 4x, turn this into x squared plus 7x plus 12, and factor using another strategy that you know. More power to you if you can do that. But for now, this is a skill that's important, so I'm going to teach it. So what I'm going to do is I'm going to split the halves of the problem. I'm going to put the left half with the first 2 terms in the problem, the right half with the second 2 terms in the problem, and GCF factor each separately. So I'm going to look at x squared and 3x kind of separate from each other, the x squared plus 3x, and I'm going to GCF factor it. When I look at those terms, they both have an x, and the smaller of the exponents is that second x to the first. When I GCF factor those, I'm going to factor out an x, and then fill up a parentheses with what's left after you remove an x from the x squared, and when you remove an x from the plus 3x. From the x squared, if I remove an x, I'm left with 1x because it started with 2 and I took 1 out. I'm not going to change the sign because I didn't factor out a negative, so I'm just going to bring down the plus sign. And from the 3x, when I factor out an x, I took the x away, I'm left with a 3. I'm going to bring down the plus sign that I wrote after the splitter bar. And from 4x plus 12, I'm going to do the same style. I'm going to factor out a common factor. I'm going to GCF factor 4x plus 12. Since the 12 doesn't have an x in this GCF factoring, I can't factor out an x because both terms to the right of the vertical bar don't have an x. But 4 goes evenly into 4 and 12. In fact, it's the biggest number that goes evenly into 12 and 4. So I'm going to factor out a 4 and put it in front of a parentheses. To fill in my parentheses, in my mind, I'm going to divide each of the numbers by 4 that I've just shown the division for. The first division, the 4's will cancel. I'll be left with a 1x. I don't need to write the 1. I bring down the plus sign because I didn't factor out a negative, and the 12 is going to turn into a 3 when I factor out a 4. Now I'm basically done because this is like the ending problems in section 5.1. I see the common parentheses, which should be part of my answer, and the second factor is going to be the number and variable in front of the common parentheses. When I go to write a factored answer that has 2 parentheses, The order that I write the parentheses in is completely up to me. There are two correct answers for problem 2. X plus 3 times x plus 4 is as correct as x plus 4 times x plus 3. It turns out that the second version, if I go into checking mode, is the better way to write. So I'm going to check, and anytime I factor, if I can check, and the process of checking is clearing the parentheses, clearing the factoring, and trying to match up with the original problem. So that's what I'm going to do now. I'm going to check by foiling. I'm going to multiply the firsts, which are x times x, which give me an x squared. I'm going to multiply the outers, which are x times 3, and that's a positive 3x. I'm going to do the inners. That's a 4 times x. That's a positive 4x. And I'm going to do the lasts. That's a 4 times 3. That's a positive 12. Because that identically matches the original problem, I'm going to say my factoring is correct. I can do that every single time. I can check exactly the same way. And the having the common parentheses second is the version that you'll probably want to check if you're going into checking. It will make the checking work perfectly. I'm going to slip down to number 4 and do the same strategy. So anytime I have 4 terms and I'm asked to factor, grouping is the strategy that I generally use. There are some real subtle strategies to factor with 4 terms, but boy, they almost never come up, and we don't teach them in our class. So I'm going to split a left half and a right half. Anytime I have 4 terms, I'm going to factor by grouping. I split right down the middle, a left half and a right half. The difference between problem 2 and problem 4 gets to be to the right of this vertical line that I just put in. When the first term to the right of the vertical bar has a negative in front of it, you're going to have to factor out a negative with the GCF. So I'm going to first factor the common factor from the x squared minus 3x. It's the same x as above. This problem was almost the same problem. And it has similar common factors. The common factor between the x squared and the 3x is the x, because both terms have an x, and the second x is the smaller of the 2 exponents of the x terms. When I factor out an x, I'm left with an x minus 3. To the right of the vertical bar, it's super important to factor out a negative with the common factor, because the first term has a negative in front of it. So I factor out a negative because the first term is negative. I have the same number of 4 for my common factor because I have the same 4x plus 12. The difference is filling up the parentheses. It gets to be a little bit trickier when you have a negative in front of your parentheses. I need to switch signs and divide by 4. So this negative sign, it's going to turn to an implied positive. Instead of writing in plus sign, the plus sign is going to be implied. And the 4 that was in front of the x, because I factored out a 4, in my mind I'll divide it by 4. And to lead off my parentheses, I get a positive x. The implied positive sign because the negative sign switched to positive. The implied 1 because the 4, when you divided it by 4, it turned to 1. Because I'm factoring out a negative, the positive sign in front of the 12 needs to flip to minus. Because I factored out a 4, the 12 needs to change to a 3 because I'm technically dividing by what I put in front of the parentheses. Now I'm ready to write my answer. I see the common parentheses of x minus 3. That's going to be one of my factors. And then the x and the minus 4 that's in front of my common parentheses will be the other answer. If I was going to check, this version's the better version to check. It'll check directly without any playing around. I'll do 6 and 8, and then eventually I'm going to start skipping some problems because these things get real repetitive. So in the world of number 6, it has 4 terms, and I'm teaching factoring by grouping. I'm going to factor everything by grouping. You'll notice I'm using a purple marker, for lack of a better word. This is because I was editing another teacher's work this summer, and she's developing a 115 course as well. And she did this vertical bar, which I didn't used to do when I taught factoring by grouping. I liked it so much that I decided that I was going to change a lot of the work that I did in this chapter. So when you see this purple marker, it's because I liked somebody's work better than mine. So same style. I put my vertical line in. Left half, I'm going to pull out the common factor of x and be left with an x plus 1. I don't have to worry about factoring out a negative, so I'm just going to bring that plus sign down. And between 36x and 36, I can see the common factor. They both have the number 36, so I know I can factor out a 36. The second 36 doesn't have an x, so I can't factor out an x. When I factor out a 36, since it's positive, I'm not changing any signs. And to figure out the contents of the parentheses, in my mind, I would divide each of the 36s by 36. This first division is going to give me a 1, which I'm going to make an implied 1 and just write the x that's left over. And then after the plus sign that I bring down, you get a 1, because 36 divided by 36 is 1. And then I write my common parentheses and the x plus 36 that's in front of my common parentheses. And never is it wrong if you have the same factors in an opposite order from me. I'll move on to number 8, do the same strategy. These are super repetitive. There's only 2 tricks, and we've learned one of the tricks, having to deal with factoring out a negative. If the sign to the right of the vertical bar is, first sign is negative, then I need to factor out a negative with the GCF. Very repetitive. If you're good at GCF factoring, this is not hard. For the x squared minus x, I get a common factor of an x, and I'll be left with an x minus 1. To the right of the vertical bar, I need to factor out a negative because the 36 has a negative in front of it. I need to factor out a 36 because that's the biggest number that divides evenly into both the 36s. I can't factor out an x because the second 36 doesn't have an x. So I need to change signs and divide by 36. So this negative sign is going to turn to an implied positive sign. This 36 is going to turn into a 1, and I'm going to be left with a positive 1x. The positive sign's implied, the 1's implied. This plus sign, because I'm factoring out a negative, needs to flip to negative. This 36, because I'm factoring out a 36, I divide 36 by 36 and get 1. If you don't get a common parentheses, then the problem doesn't factor, or you've made a mistake. And in this section, it means you've made a mistake. Every single problem in this section, if you double factor properly, you'll get a duplicate factor. Both of those are correct answers. So now I'm going to go into the world of just doing one problem per page, because I don't think I need to do so many. And 12 looks harder than 10, so I'm going to do 12. So in the world of number 12, I split my halves. To the left of the vertical bar, I do my first common factoring. To the right of the vertical bar, I do my second common factoring. And that second common factoring, I need to factor out a negative because the first term is negative. To the left of the vertical bar, I factor out the common factor of a y, and I'm left with a y minus 6. So I'm just assuming you could common factor without me explaining it. So if you need to pause the video and do the common factor factoring because I'm doing it faster than you can, that's completely fine. But I can't, well, my videos are too long as it is, and then if I explained everything that I should explain, then it gets to be too long. So I'm just hoping that you can do the common factor factoring without my explanations. To the right of my vertical bar, the first sign is negative, so I need to factor out a negative. Both terms don't have a y, so I can't factor out a y, but 5 is the biggest number that goes evenly into 5 and 30. So in front of my second parentheses, I'm going to get a negative 5. And when I factor out a negative, sign switch. So the negative sign that's in front of the 5y goes to positive, but it's an implied positive. I don't write the plus sign. The 5 that's in front of the y, I divide by 5 and it turns into 1. That's another implied. So when I write y, it really is positive 1y. This plus sign, when I factored out a negative, it needs to flip to negative. And this 30, when I factor out a 5, I need to divide it by 5 and get 6. Again, you get the duplicate parentheses. You've got to get the duplicate parentheses. If you're not getting the duplicate parentheses, you did some common factoring wrong, because all of these problems are going to work perfectly, and that if you do the first step, the double GCF factoring properly, you'll get 2 identical parentheses. In 13, 14, 15, and 16, I just feel like 16 is harder, and I'm going to start doing one problem per page to make the video an acceptable length. So I'm going to factor 16. It's harder. If you could do 16, you can do 14. So I split it into equal halves. I have a left and a right half. On that right half, I need to factor out a negative. For 5x squared minus 10x, I'm going to factor out a 5, because 5 is the biggest number that goes evenly into 5 and 10. I'm going to factor out an x, because both of those terms have an x, and x to the first is the smaller of the exponents. To fill in the parentheses, I'll divide the numbers by 5, or the coefficients by 5, and take an x away, and be left with x minus 2. To the right of my vertical bar, I'm going to factor out a minus, because the first term is negative. I'm going to factor out a 3, because 3 is the biggest number that goes into 3 and 6. I'm not going to factor out an x, because that 6 doesn't have an x. Inside my parentheses, this negative sign goes into an implied positive sign. I don't write the positive sign, but it's a positive number. This 3, I'm going to divide it by that 3. It's going to turn into an implied 1. I'm not going to write it before the x, but in front of the x there's an implied plus and an implied 1. I didn't factor out the x, so I left it. This plus sign is going to flip to minus, because I factored out a negative. This 6, since I factored out a 3, it's going to turn into a 2, because I'm going to divide the 6 by 3 and get 2. So for an answer, I'm going to write x minus 2 times 5x minus 3. And you can flip-flop the order. And maybe I should do 18 and 20 on this sheet, just because they have a same trick but not exactly the same. So I'll do them both just so you can see the one trick that we haven't got to yet. In problem 18, I'm asked to factor by grouping. I'd only be asked to factor by grouping if the problem either is given with 4 terms, or I could rewrite it with 4 terms. Grouping is only applied to problems with 4 terms. So in problem 18, I split my halves, made a left and a right half. Left half is nothing fancy. 4 is the biggest number that divides evenly into 4 and 12. Both terms have a y. The smaller of the exponents is that y to the first power. So for my first factoring, I'm going to factor out a 4y, which makes me divide the numbers by 4 and take a y away. Leaves me with a y plus 3. Bring down this plus sign, and in this second factoring, both terms don't have a y, so you can't factor out a y, and the coefficient of the y is a 1, and the biggest common factor between 1 and 3 is a 1. So there really isn't a common factor between between the y and the 3. When there isn't a common factor, you need to make one up, and it's not really made up. It means if there isn't a common factor, there's a generic 1 as its common factor. And if I factor out a 1, I just leave the contents the same. So that y plus 3, when I factor out a 1, is just going to be, I'll have a y plus 3 in the parentheses, because if I cleared the parentheses by multiplying by 1, I'd get the y plus 3 back. So if there isn't a common factor, you need to factor out. a 1 to produce the parentheses that will enable you to see the double parentheses or the common parentheses so that you can factor properly. Either one of these answers are equally good. In 20, which is kind of the sister problem to 18, I have to do something even a little bit more advanced. So in 20, I split my halves. Left half is basically the same factoring as 18. Right half, not so much. Left half, I'm going to factor out a 4y again and be left with another y minus 3. To the right of the equal sign, there's similarly not a common factor, just like the y plus 3 above it, but the difference in this version is the first term has a negative in front of it. I wrote the 1 just to emphasize the 1 because I like to see that. And when there's not a common factor and the first term leads with a negative, you need to factor out a negative 1. And when you factor out a negative 1, that just causes you to switch signs. The negative 1y is going to turn to a positive 1y. I could leave the 1 as assumed. The positive 3 will turn to a negative 3. So now I see my common parentheses, which is going to be half of my answer. And then the 4y and the minus 1 that's in front of the parentheses will be the other half of my answer. I'm going to go back into skipping problems, trying to keep this video under 40 minutes. I'm going to do 24, even though 22 has the factoring out of a negative. I've done a lot of negative factorings out, so I don't mind skipping one of those. You might be to the point now where you don't need to watch any more of the video because you already can factor everything that I can throw at you. So for 24, I made my left half and my right half. For my left half, I'm going to factor out a 2 because that's the biggest number that divides evenly into 2 and 14. I'm going to factor out a z because both terms have a z, and that second z is the smaller of the exponents. Notice I write down an equal sign saying what I'm writing is equal to the line above it. When I factor out a 2z, I'll be left with a z minus 7. That 2 gets divided out. I had 2 z's there and I took 1 away, so I'm left with a z. Bring down the minus sign. I'm not changing signs because I didn't factor out a negative. And this minus 14z, I took the z away, so I don't have a z after my minus sign. And the 14, I'll divide it by 2 and make it a 7. To the right of a plus sign, there isn't a common factor between z and minus 7, so I'm just going to put the imaginary or the implied common factor of 1 out in front of a parentheses that contains that entire z minus 7. And this will allow me to write my factors. Just a few more problems and we'll get up to that 30-minute window that I don't like to go much longer than 30 minutes. I'll do 28 next on this sheet. And again, if you can just pause the video, do the odd problems on this and not watch me do so many problems, that's better than watching me do everything. Once you get to the point where you don't need me anymore, then don't use me. Just go off and do it yourself. For 28, I'll start off between the z cubed and the 5z. I'm going to factor out just a z. It's the smaller of the exponents. And I don't get a number for my common factor because of the 1 that's implied in front of the z cubed. Now I'm just going to take a z away from each. The z cubed is going to turn into z squared when I take one of its 3 z's away. The 5z is just going to turn into 5 when I take its z away. I forgot the plus sign here, but it doesn't matter. I can put it in now. And then after the plus sign, 10 is the biggest number that goes evenly into 10 and 50. So I can put a 10 in front of the second parentheses. And the 50 doesn't have a z, so I can't factor out a z. So for each term, I'm just going to divide by 10. The 10z squared, I'll divide by 10 and be left with just a z squared. I'll bring down my plus sign. I'm not changing any signs because I factored out a positive. This 50, when I factor out a 10, I'll divide 50 by 10 and get a 5. Got the common parentheses that I needed. Forgot the equal sign that technically makes it more mathematically precise. And I'm going to write my answer. I generally write the common factor first, followed by what's in front of the parentheses, common parentheses second, but it's not a deal breaker if I don't. 2 more problems. We'll be up at 30 minutes and we'll call it quits. I'll do 32. Sneak a 1 in front of that minus x because it just helps me. To the right of the vertical bar, I need to factor out a negative because the first term is negative. To the left of my vertical bar, there's a common factor of x squared. Both terms have an x, and the smaller exponent they have in common is this 2. The x cubed, when I take 2 x's away, I'm left with 1x. I bring down the plus sign because I don't change the signs when I factor out a positive. And when I take the x squared away from the 9x squared, I'm left with a 9. To the right of the vertical bar, there isn't a common factor between a minus x and minus 9, but because the first term is negative, I need to factor out a negative 1. A negative because the first term is negative, a 1 because there's not a common factor. Now I'm going to switch signs, and that's all I'm going to do. The negative 1x is going to turn to positive 1x. The negative 9 is going to turn to positive 9. And I get that lovely common parentheses that I have to get when I'm factoring by grouping. This is a special problem that if you have knowledge that's beyond what you should have right now, you might have instinctively factored this. In section 5.5, we'll learn how to break that x squared minus 1 into 2 different parentheses, and by the time we get to the end of the chapter, had I given you this same problem, the best final answer would be this, but this is not knowledge that you should have. This is, it's best, it's a better answer, but it's not really appropriate for right now. But if you just instinctively, because you remember how to factor and that you knew how to break that into 2 parentheses, if you did this extra step, well, then you're way ahead of the game. And boy, you probably should have been in a higher level class than this because you know some stuff that is, pretty well necessary for the next class. But this is what I'm teaching, and maybe this class will be easy for you if you can do that kind of stuff. One last problem gets us up to that 30 minutes. Let me do problem 36. Asked to factor 4x cubed plus 5x squared plus 12x plus 15. Make my left half my right half. On my right half, I'm not factoring out a negative. On my left half, between the 4x cubed and the 5x squared, I'm going to factor out an x squared and be left with 4x plus 5, just taking 2 x's away from each term. Bring down the plus sign, and 3 is the biggest number that divides evenly into 12 and 15. I'm going to factor out a 3 for my second common factor factoring. Divide the numbers by 3, not change any signs. Get my duplicate parentheses for one of my factors, and then the x squared and the plus 3 that's in front of the duplicate parentheses will be the other factor that I need to write in my answer. And always these problems, the order that you choose to write your answers in is just a matter of personal preference. So hopefully this feels good. We'll lead off section 5.3 doing grouping again, and then we'll leave grouping for a little bit, and then all of section 5.4 is going to be grouping. So this is an important skill, just like greatest common factoring is an important skill. So let me pause and we'll move on to section 5.3.